Hello and welcome to the Future of XYZ. So happy to be here today speaking about the future of data integration with Dr. Eric Daimler. Eric, thank you so much for joining us on Future of XYZ.
Good to be here.
So you obviously have quite an esteemed background, I have to say, as a serial entrepreneur, as a graduate of Carnegie Mellon University, where you got a PhD, I believe, in computer science, and you teach it there in computer science, but also Stanford University and University of Washington, Seattle. Besides the fact that you were a Presidential Innovation Fellow in robotics and AI during the Obama administration. I mean, that's pretty remarkable.
It's a good time.
I bet it was. I mean, I think if we're talking about data integration, we'll talk about your current company, Conexus, and what you all are doing to really kind of change the shape of data in the world. Let's just start out. What is data integration, just to level set for our audience?
Sure. It's really bringing data together, bringing data to bear for consideration of decisions, business decisions, public policy decisions, whatever sort of decisions. Mizuho Bank in Japan did one of those upgrades that we're all familiar with over a weekend across their network. That was on a Saturday night. Come Sunday morning, their system didn't come back up as they intended. Monday morning, their system still didn't come up. So as consumers of Mizuho Bank, we wouldn't have had access to our bank accounts. We couldn't have sent or received wires for all of a Monday because of a data integration problem. It's these massive databases that just don't want to talk to each other. This happens in every business. It happens in every government. This really explains the problem with data with healthcare.gov when it initially launched in the Obama administration. Mismatched data doesn't want to talk to each other. Data integration is the technology and the approach for bringing this data together so that it can make useful business decisions.
It's interesting because one of the terms that as a marketer, as a strategist, we often talk about is BI, so business intelligence. Once upon a time it was competitive analytics, and it's this combination of internal and external data sources that you analyze, bring into dashboards, reports, whatever it is, to help make business decisions and strategic planning, really, but as data has exploded, I mean, I think that's really what we're talking about in some ways here. You have different systems and different inputs and different languages, right? And so what you're talking about integration is how systems and I guess various sources can connect so that you don't have banks go offline for 3 days at a time.
Yeah, if you and I work with Excel and we have maybe thousands of rows, maybe a couple of hundred columns, we're good. But if you want to say integrate these two different databases, two different Excel spreadsheets, that'll take you a little bit of time. The problem with the data explosion, big data is somewhat of an old term right now. No kidding, data is growing exponentially. 90% of all data has been created in the last 2 years, and that continues. What's little known is that the number of data sources is also growing exponentially. And in that, there's a problem. The future of the world is not really in this big data, it's in the data relationships. In the data relationships, everything is possible, but everything is breaking. The scale with which these data sets are growing, therefore the scale of the data relationships is growing beyond the infrastructure's ability to handle it. We've recognized this now for a while. There are companies founded in the 1980s like Informatica and Ab Initio to try to solve this problem. There were technologies in the early 2000s around RDF and OWL invented to try to solve this problem. But what we found is the problem actually isn't solved in computer science. As much as I would like to think of myself as a bright computer scientist, the level of the problem actually is getting solved in math, a sort of law of nature. There's a branch of mathematics called category theory, categorical mathematics, we might call it, that is fundamentally different than what is currently powering much of the software in our infrastructure. We wouldn't have really relational databases, Oracle and all that, without relational algebra, which was brought up in the early 1970s. We're now entering a new phase, category theory, and that math is going to really wipe the slate clean over the next 10 to 20 years. Everything will change.
Well, I want to talk about some of these mathematical solutions and then also what Conexus, your current company, does and is doing. But I want to just backtrack for a second. It's a topic that's close to my heart, and you may or may not have any opinion on it, but I'm going to guess that during the Obama years and as you look towards, this Biden administration, one of the things that comes to my mind, of course, that separate and apart from the integration of data, but is the more data, the more sources that we have, the more clouds that we have containing all of this, the more server farms and the more energy is actually being utilized, true, actual energy that needs to be created to manage this. Are there mathematical solutions, or is that an engineering problem that needs to be addressed? Like, is this one and the same that we can collapse in integration so that you can use less, or is it a totally different thing?
It's a good question. This is a multifaceted problem, but on that particular issue, this technology, this math, gets expressed as not requiring bits to be moved. A lot of what happens in these centralized databases is the collection of bits from around the world into one big open warehouse of bits. And it's really done quite poorly. We hear these terms data lakes. Sometimes there's lake houses, there's master data management is kind of a less known term, and BI. Those terms allow for data to be brought together and thrown in a data warehouse is another term. And it's a little bit like throwing books into a library and then saying, oh, good, it's all done now, it's all integrated, without a Dewey Decimal System or some manner of retrieving the books. It's really quite useless. What are you going to do? Sort by book color or size or height? That's what happens right now with data integration. And that contributes to these massive data centers needing to be developed. What we did for Uber, for example, is we worked with them to bring together their data around the world without creating some sort of massive central repository. Uber is a little bit like every government and every other company, which is they're not focused on having an optimal IT infrastructure. They're focused on their business. They're focused on solving what's in front of them. And in Uber's case, they grew up trying to match supply and demand city by city. Right. Those cities have different characteristics with regard to weather and obviously labor demand, labor supply and customer demand. They also may have regulatory differences. Yep. They needed to solve that problem. And right now, they couldn't. They would ask a business question, so business intelligence, how does weather affect the number of drivers I need to incent to be on the road? They could ask that for New York City. They would have to do that separately for Philadelphia and then do a statistical comparison between the two. That added to a certain amount of friction, both in time and in money. They looked around the world about how they could solve that problem. They found the solution would be in math. Then they happened to find who's the leader in the software expression of this math and category theory. They found us, Conexus. And Conexus worked with Uber to create a solution for them to integrate their cities so that they could compare the whole world and have them tell it. We save them millions of dollars a year, which in a low margin business is makes a big difference.
I know. It's actually fascinating. It's a great example. So talk to me a little bit about specifically what Conexus does, because I can picture that having, run marketing departments and strategic projects in large, organizations that span globally, especially, and span categories, et cetera. And it's almost like apples and oranges sometimes. I mean, the data doesn't integrate, and then you do a comparison to X and Y, and then you figure out what your statistical significance is of the difference. So all of these kinds of things come up, I think, for people on an everyday basis. So what is Conexus's solve? You say math and you talk about category theory, but specifically what does Conexus offer?
We allow data to scale, and we allow data relationships to scale verifiably, provably, so that you can scale infinitely with the rate of data and data relationship growth with guaranteed semantic integrity, meaning the meaning of the data and the meaning of those relationships is guaranteed to be preserved. That means your bank isn't going to go offline. That means your airplane design isn't going to blow up. That means you'll be able to know where your personal protective equipment is on a container, on a ship, in which ocean. It means that us as customers are working with more efficient financial institutions, and our data is properly preserved in the privacy of the regulations in place. Those sort of guarantees are really only possible with the implementation of this level of math.
And so it's super interesting, actually, and it's probably above my pay grade, to be very candid, speaking with a PhD from Carnegie Mellon in computer science, because, you know, this is definitively not my jam. So I think, you know, but I find it fascinating, especially because there's so many words out there today, you know, that are being thrown about, and they are technologies of the future, right? I mean, and two that come to mind when you're talking about like knowing where your PPE is in a container on a specific ship, and especially when we just had, you know, Hurricane Ida, for instance, or we're having the crisis in Afghanistan, or where Haiti, where supplies need to get, you know, in a humanitarian crisis kind of way. You know, you think about how that can be leveraged, and one of the things that comes to mind is blockchain, right? Blockchain is like knowing where things go, but it's a hot topic conversation, as is AI, artificial intelligence. This technology that you are building at Conexus, does it work with blockchain? Does it work with AI, or are these completely separate ideas?
They're completely complementary. So blockchain complementary. This technology would be applied in blockchain to create smart contracts. So Ethereum is currently the leading supplier provider of a smart contract using blockchain, but that's a broken system, really will never work. But if somebody wanted to create a new smart contract system, they would use category theory. They could use our system or others being developed and apply that to the development of an Ethereum competitor. So that's blockchain. In AI, what's helpful to remember is that most of what gets in the press is in probabilistic AI. So it's specifically in neural nets, which is a type of machine learning, which is a subset of AI. We have that, and we use that as appropriate, but most of what our category theory is doing is using symbolic AI, good old-fashioned AI. And so that's deterministic. The benefit of deterministic AI is the end result is proven. There's no probability in it. And this is really appropriate if you are diagnosing cancer or flying a commercial jet aircraft. You want things to have zero tolerance of failure. If you're doing digital advertising and the probabilities are okay, a lot of nice problems can be solved over in that other domain of probabilistic AI. I am of the opinion, and there are different opinions, that there is beauty in the combination of these two types of artificial intelligences, depending on the particular use. Andrew Ng is a popular AI personality that agrees on my side. Some of the people like Jeffrey Hinton that are pioneers in neural nets think that that's the future by itself and alone. But those are different types of AI. That's kind of down the rabbit hole. But the AI
it's super interesting though, because I've never heard either of these terms before, right? And I've worked with companies who do AI, so I'm super excited about this.
Yeah, I mean, those are beautiful technologies, and they have their place. The application for your listeners really is to understand where we as humans want to stop these algorithms from operating and have a human intervene. The danger of these AI technologies is manifold. One that's often in the popular press is about bias. All data is biased, and solving that problem is going to be really an ongoing evergreen challenge. It's our job to look at where that is going to be put into practice, this biased data and these algorithms, to say, hey, where do we stop that? Where do we have a circuit breaker? Where do we have a human audit to oversee these otherwise seemingly magical technologies that can save lives and increase our life?
So really, this should be called the future of data integration and human intervention.
Having spent time in the federal government, I definitely have developed some opinions around public policy implementations for the AI technologies.
I can absolutely imagine that. And so I mean, let's just talk about that for a second. I mean, I want to think about the feds. We have this huge infrastructure bill that, you know, in varying forms is passing and going, and, you know, we're moving things forward little by little, right? So my question for you, having sat in the Obama administration for a time working on robotics and AI kind of things, you know, we are falling behind. I mean, it's certainly by comparison to countries like China, but to many, many countries in the world. What is your hope for, you know, the future of, let's just call it data integration, but really about all of these other technological tools that we're thinking about in America and for the world at large?
Yeah, I actually am more optimistic about America's future in digital technology, information technology. Really, it's in my view that the one area that China is ahead of the US, maybe ahead of the West, is actually in chemistry. In chemistry, the Chinese seem to be ahead of us in pure research. You know, the Chinese have certain advantages around data privacy, most popularly, but the U.S. is in a great position, and the West is in a great position. My concern, kind of really my hobby, I guess, is making sure that people are involved in the conversation. The best thing that the U.S. could do to maintain competitiveness, aside from funding research, aside from bringing semiconductor manufacturing capacity onshore, the best thing the US could do is make sure that the technology created is embraced, not resisted. And that makes sure that we have everybody on the field. Everybody on the field. Everybody needs to be involved in this conversation. You know, not just arbitrarily. You don't want to accept these things blindly, but everybody needs to be involved in where the strengths and weaknesses of these implementations are. These are automation systems, so it's helpful for your listeners to be thinking, well, what do I want to be automated, and when do I want that to stop? Right. You know, the danger is linking automation with probabilities so that you can magnify errors at the end. And some people are going to feel ripped off, I guess we can say, at the end. That's for all of us to get involved. You don't need to have a computer science PhD to have that conversation.
No, in some ways, it's a moralistic question, frankly, and a common sense question.
Exactly.
Right. And I think we look at, you know, I look at privacy. You mentioned, you know, China has some different leeway than we do. But I mean, the Europeans are much tighter than we are. You know, we live in a global world. And if anyone wants to argue otherwise, I think data is the number one place where it's so obvious we live in a global world. You know, data, to your point about, you know, warehouses of bits, you know, the bits travel around the world. They don't have frontiers. They don't have national boundaries. They don't need to give a passport, but they are regulated differently. So when we start thinking about category theory in this, like, does your data integration future exist across borders kind of in a seamless way, or what does that look like?
Yeah, so one of the applications of Uber was exactly what I said, was trying to make better business decisions around such pedestrian things as supply and demand. No pun intended. But there is another use, which is regulatory sensitivity. So in one jurisdiction, a driver's license number may be considered to be the most private of personal identified information. In another state or another country, the license plate may be considered to be the most sensitive piece of personal protective information. So those particular sensitivities on a privacy lattice need to be respected across countries. I was talking to a senior official in the Gulf region, and he was exploring how the data is taken from its citizens, exported to a Google farm, data farm, and then imported back into the country with ads as some sort of value that's being extracted from the country and then resold back to the country to its own citizens. That sort of sensitivity around data and data flows is the future. We're all going to need to be prepared to have those conversations globally.
Okay, so I mean, we're just about at time, Eric. So I want to ask, like, the classic, you know, sci-fi of the future question when it comes to data and AI and all these things. I know you've kind of answered, you're pretty bullish on America, but like in general, like utopia, dystopia, like, and what's the threshold? I mean, besides that human intervention.
Yeah, dystopia, utopia, neither and both. The whole idea of AI becoming becoming sentient, I think, is a distraction. Nick Bostrom at Oxford, smart man, smart researcher, a good book that he's written about it, and it is as much of an existential threat as he says. But I'd say the majority of AI researchers will bet that that sort of sentience will never occur, and certainly unlikely in our lifetime. I can get into that about why I believe that, but it really misses the point for many of the people discussing it, because AI doesn't need to become sentient to become very, very dangerous. You know, we see this in just everyday living around the distortion and manipulation of our behaviors. You know, it's analogous to, but much, much worse than the lack of control that I have over having potato chips. You know, because there are companies that understand my physiology more than I do. And so I can't have a potato chip. I can't have just one M&M. That knowledge is owned by these companies, and that problem, the ability of other entities to manipulate my behavior and me thinking that I have free will around that is very dangerous, and that has nothing to do with sentience.
Right. That's so interesting and quite dystopian. And as a marketer who spent a good amount of time in the consumer packaged goods arena, I certainly know what you're talking about with those potato chips and M&Ms. So data helps, but it's not everything. Interesting. Well, Eric, thank you so much for joining us on Future of XYZ. It's been a pretty robust, to put it mildly, conversation in 20 minutes, but it's really a pleasure to talk about the future of data integration with you.
It was a good time. Thanks for having me.
Absolutely. And for all of our listeners, if you're not already subscribed, make sure that you do. You can find Future of XYZ on YouTube and on Apple, Spotify, Amazon, wherever you get your podcasts. And of course, follow us on Future of XYZ on Instagram. We look forward to seeing you the next time. And it will be next Thursday.